All right, I'm going to go over the notes from 11.6, which is the volume of a sphere. So a sphere is a ball-shaped solid. Half of a sphere is called a hemisphere. And to find the volume of a sphere, the formula is going to be 4/3 times pi times r cubed. The volume of a hemisphere is half of that, so that's going to be 2/3 pi r cubed. And in class, we did an investigation where we derived this formula. And let's go ahead and do some examples. So we're going to find the difference in the volumes of the two spheres below. So we have the larger one and the smaller one. And so the volume is going to be 4/3 pi 6 cubed minus 4/3 pi 3 cubed. And so that's going to be 4/3 pi. And just to review, 6 cubed is 6 times 6 times 6. And 3 cubed is 3 times 3 times 3. So this is my calculator here. Let's see what I get. I'm going to get 288 pi. And I'm going to subtract off 36 pi. The result will be 252 pi centimeters cubed. And I'm done. Next problem, find the volume of plastic to the nearest cubic inch needed for this hollow toy component. The outer hemisphere diameter is 5 inches and the inner hemisphere diameter is 4 inches. So what we're going to do is find the volume of the outer and the volume of the inner and subtract them. So the volume of the outer is equal to 4/3 pi. Use uppercase R to indicate the radius of the outer. It's going to be 2.5. Lowercase r be the radius of the inner, which is 2. So the inner would be 4/3 pi r cubed. Okay, and again, 2 cubed is not equal to 6 because 2 cubed is 2 times 2 times 2, which is 8. It's not 2 times 3. So when we do the calculations, we'll get that the volume is equal to 2/3. Oh, it's 2/3. Where is my head? It's a hemisphere, right? So it's 2/3. And there we go. Okay. So that's 2/3 pi and times 15.625. And that's 2/3 pi times 8. So that means the volume of the outer is going to be approximately equal to 32.7. And the volume of the inner, it's quite the I there, approximately 16.8. Okay. So that means the volume is going to be the outer minus the inner. And that's going to be approximately equal to, oh, I should do approximately. Hold on here. 15.9 cubic inches. And I'm done. Okay. Next one is an exercise for her art class. Mona has cast a plaster cube 12 inches on each, 12 centimeters on each side. Her assignment is to carve the largest possible sphere from the cube. What percentage of the plaster will be carved away? So we have a cube that's 12 by 12 by 12, making the volume of the cube and the volume of the sphere well, if the sphere is inside that cube, the diameter of the sphere is 12, making the radius 6. So it's 288 pi. So how much of the material is going to be scraped away if you start with the cube and scrape away the material until you get to the sphere? That's going to be the volume of the cube minus the volume of the sphere. That's the volume that's removed. $1,728 minus 288 pi, 823. Okay. So then if that's how much is removed, we're going to take that number and divide it by the total volume of the block times 100%. And that will result in the percent that's removed. That's actually going to be approximately equal to 48%. So you get about 47.6, so you round it up to 48. Okay, that is the third one. Now for the fourth problem. A sphere has a volume of 36 pi meters. What are the dimensions of the cube that will circumscribe the sphere? So the volume of the sphere is 36 pi. That's equal to 4/3 pi r cubed. First thing I'm going to do is divide both sides by pi. So that's 36 is 4/3 r cubed. Cancel pi from both sides. And then multiply both sides by the reciprocal of 4/3. That's 3/4. And that ends up being 27. Now what you're going to do is take the cube root of both sides. And we get 3 equals r. And that means that the cube, excuse me, the cube will be 6 by 6 by 6 cubed, since the diameter of the sphere is going to be 6. All right. Well, that concludes the notes for 11.6.